to welcome everyone back to class today. Hope you had a good weekend, and let's fix things up right where we started. So first and foremost, did anyone have any questions over solving quadratic equations using the quadratic formula? If you do, please raise your hand and I will be more than willing to clarify those problems. Alright, so if no one has any questions, I want to proceed and go on to the next section, which is section 9.4 in your textbook. And it discusses another technique with which we can solve quadratic equations. So what are the things that we know, or what are the formulas that we know with which we can solve quadratic equations currently? Oh, hey Josh, do you have a question? Yeah, okay. Graphing is one way in which you can solve quadratic equations. What is another way? Oh yeah, completing the squares, of course. That's another way in which we have learned how to solve quadratic equations. But today I want to discuss something new. What if you can't factor and cannot use a graphing calculator to solve a quadratic equation? What other choices do we have? Well, the other choice, and something that always works, is known as the quadratic formula. How do we get the quadratic formula? That's a pretty interesting point, and that's exactly what my next point of order is. So let's start off with the general equation, which is in quadratic form. So if you look at it over here, you have the quadratic general form, which is ax squared plus bx plus c is equal to 0. What we want to do is solve this equation such that we can solve it with respect to x. So what's the first thing that we do? Well, the first thing I want to do is take the c, which is a constant value, and subtract it from both sides of the equation. Why do we subtract from both sides? Well, because if you do any action on one side of the equation, you have to always do it on the other side of the equation in order to keep things balanced. Everyone with me so far? Alright, good. So now that we're over here, what we want to do is we want to make the x squared term independent of any constants. So right now it is being multiplied by a coefficient, which is a, and we want to get rid of that coefficient. So how can we do that? Oh, Emily, you had something. Yeah, that is correct. We can divide both sides of the equation by a, and that will allow us to make x squared independent of any coefficients. So that's exactly what we do in the next step. And you notice x squared has no coefficient associated with it. When we do the same division for the bx term, it becomes b over a, and c becomes c over a, or negative c over a. Alright, so now we have something that everyone should be kind of familiar with. We have constant on the left side of on the right side of the equation, and simultaneously we have an incomplete quadratic on the right side. So how do we solve this? Well, what are the techniques that we know? Somebody mentioned graphing at the beginning of class, and the other technique that we mentioned was completing the square method. So let's try solving this by using completing the squares. I'll give you guys a moment to try and do it on your own. I hope everyone had sufficient time to try and figure it out. If you didn't, then here's the solution for it. The correct term by which we have to, the correct term that we have to add on both sides of the equation to complete the square is b over 2a. And if you notice, that's exactly what we're doing in the next step. And the step after that follows through from the one above. Now that we've completed the square, the left side of the equation can be represented as x plus b over 2a, the whole thing squared. The right side of the equation, for balance reasons, is now simply negative c plus b squared over 4a. And we didn't do anything special here. All we did was figure out the exact term that is needed in order to complete the square on the left side of the equation. And then, in order to keep things in balance, we had to do the exact same thing on the right side. Everyone with me over here so far? Alright, looks like everyone is clear over here. So, step after that, all we do is represent it in a closed square form. So, here you have x plus b over 2a, the whole thing squared is equal to negative c plus b squared over 4a squared. This is nothing more than a simplification from the step above. And once we simplify this step, what we result with is x is equal to this formula, which is negative b plus minus square root of b squared minus 4ac over 2a. Alright, so this is what we refer to as the quadratic formula. And these steps were a logical sequence which you can use to actually come up with a quadratic formula. Once you have the quadratic formula, it is a universal tool that you can use to solve any kind of a quadratic system. It doesn't matter whether it can be factored, it doesn't matter if you have a graphing calculator available. If you have these coefficients and this formula, you're able to solve any quadratic system. Alright, any questions or comments? Any questions in general? Alright, so let's proceed on and take a look at how we can apply this theory onto an actual application. So you will find on your desks, you will have a copy of this handout, which is labeled Word Problem Practice, Solving Quadratic Equations Using the Quadratic Formula. And what I would like to do now is for everyone to turn their seats 90 degrees clockwise. And that would break you guys all up into groups of 4. And what you will be doing is working on problem number 2 and problem number 4 simultaneously in your groups of 4. I'll give you guys a little bit of time to work on this and walk around to see if everyone is on pace. Questions? Feel free to raise your hand and I'll stop by to make sure you are on track. Alright, raise your hand if you're not done solving the first 4 problems. Alright, looks like everyone got through it correctly. Alright, the golden ratio also has a really good geometric property which is displayed in the second part of this handout. So it says that another property of the golden rectangles is that the square drawn inside the golden rectangle creates another smaller golden rectangle. So this is illustrated over here. We have a golden rectangle and you use it, use this golden rectangle to draw a square within it, and a square within the leftover portion, so on and so forth, and you can continue this process indefinitely. If you do that, the whole sequence ends up repeating itself over and over, and that is something really cool to notice. Alright, any questions or problems over this handout before we move on? Alright, so let's proceed. The last thing I want you guys to take away from this class today is the way in which these problems are going to be presented to you on an exam or a test. Well, how are they going to be presented to you? In this form. This is a practice sheet for homework, and you are going to be completing problems 1, which is right here, 3, 5, 7, 17, 21, and 27 from this handout for homework tomorrow. Any questions? Comments? Alright, I presume everyone is fluent with how to apply the quadratic formula. Alright, class dismissed.